You're losing marks, and you probably don't even realize why. When it comes to Cambridge International AS and A-level biology, 9700, specifically topic 17.3 on speciation, standard revision simply isn't going to cut it. You can memorize every single textbook definition, but without knowing the precise analytical framework examiners are actually looking for, your grade boundary is completely at risk.
Look closely at this number right here, 15%. Topic 17.3, which covers allopatric and sympatric speciation, accounts for roughly 15% of your total marks in Paper 2. Think about that for a second. That is a massive chunk of your final grade hanging on just one highly specific topic. If your exam strategy here is weak, well, you're basically throwing away an easy 15% before you even walk into the exam hall.
And here's exactly why those marks just vanish. This right here is a direct quote straight from the Cambridge Principal Examiner report. It says, candidates consistently confuse key terminology, using the wrong terminology for the wrong context. Students aren't failing because they don't know what speciation is. They're failing because they mix up the vocabulary and apply it to the wrong situations. This is that painful mark-costing mistake that ordinary, everyday revision completely misses. You might know the science inside and out, but if you don't use the examiner's specific vocabulary, you literally get 0. So in today's explainer, we're going to fix exactly that.
Okay, let's dive into this. Section 1. Core Principles of Speciation.
To stop bleeding these terminology marks, we've got to rebuild your core knowledge. The assessment framework for 9700 biology targets highly distinct cognitive skills, and examiners really prioritize analytical depth. Which brings us to our first core concept, allopatric speciation. Put simply, this is speciation occurring due to geographical isolation. Think of massive physical barriers. We're talking mountains, vast oceans, wide rivers. But here's the kicker. Examiners reward candidates who make cross-topic connections. It's not just about pointing out the physical barrier. It's about explaining how that geographical isolation literally stops gene flow, creates different selection pressures, and ultimately drives genetic divergence. You've got to link this concept right back to your knowledge of mutations and natural selection to hit those top band marks.
Next up, we have sympatric speciation. Now, this is speciation occurring in the exact same geographical area. It's not driven by physical barriers, but rather by ecological or behavioral isolation. Imagine a population of insects that suddenly starts feeding on a totally different host plant right next door to their old one, or maybe a bird that develops a brand new mating call. The conceptual framework here relies heavily on systematic analysis. You've got to be able to prove, using concrete, evidence-based reasoning, exactly how a population diverges without a literal wall standing between them.
And this brilliantly illustrates the core differences. When you're comparing the two in an exam, remember that comparative analysis requires you to identify both similarities and differences. Allopatric relies heavily on geographical isolation, whereas sympatric relies on ecological or behavioral isolation. You absolutely must use comparative connectives in your answers. Support every single comparison with solid evidence from the stimulus material they give you, and draw justified conclusions about their relative evolutionary importance. Look, just dropping definitions side by side, that's not going to get you the evaluation marks.
Now here is a truly pivotal question. What is the single examiner clue that changes the answer completely? In just a moment, I'm going to reveal this hidden clue, one that dictates whether you're dealing with a geographic or ecological driver. It's sitting right there in the stimulus material. But you literally cannot spot this clue until you master the procedural framework first. So hold that thought. We are definitely coming back to this massive revelation.
Moving right along to Section 2, the method mark strategy.
So in Cambridge 9700 biology, marks are actually frequently awarded for the process itself, not just your final answer. When you're tackling those complex problem-solving or practical experimental questions on speciation, the examiner's actively tracking your logical, structured reasoning step by step. Here's the exact procedure you need to follow. First, deconstruct the question. Second, extract the relevant data directly from the stimulus materials provided. Third, select your analytical framework, like are we talking allopatric or sympatric here? Fourth, execute your reasoning with clear scientific notation. And fifth, present your final response using rigorously correct terminology. Honestly, skipping even one of these steps is exactly how top-tier students end up bleeding marks unnecessarily.
If you want to construct those highly logical, higher-order evaluative responses, you need to memorize this exact sequence: concept, then evidence or data, followed by scientific reasoning, and finally, examiner wording. This right here is the top-band answer framework.
You state the core concept of speciation, you back it up with hard data extracted from the prompt, you explain the why using solid scientific reasoning, and then you package the whole shebang in the exact phrasing the mark scheme demands. This sequence is absolutely your ultimate tool for acing these questions.
Which brings us nicely to Section 3, Critical Data Interpretation.
Historically, interpreting complex data and graphs in 17.3 speciation is where candidates struggle the most. You're going to be asked to extract data from tables, interpret relationships between isolated populations, calculate relevant stats, and draw evidence-based conclusions. But seeing our framework in action totally changes the game here. Now, what's really interesting about this slide is the clear contrast. Compare that flawed, vague student answer to the improved top-band response. The flawed answer uses super vague context and poor terminology, basically just saying the animals got separated and changed. Yeah, that scores 0 marks. But the perfect answer, it utilizes specific data extracted directly from the graph, identifies the exact behavioral isolation mechanism, and uses precise examiner wording like disruptive selection or reproductive isolation. It applies our concept evidence reasoning sequence flawlessly.
All right, I want to challenge you right now. Take a look at the data interpretation phase on screen. Let's say a student successfully identifies that 2 bird populations have different beak sizes due to different food sources, but they still get a low score. Where did they lose their marks? Take a second, pause, and predict. Did they miss an anomaly in the data? Did they forget to quote the specific stats straight from the graph? Or did they just fail to specifically name it as Sympatric Ecological speciation? Well, if you guess that they failed to use the specific data to justify their conclusion, you hit the nail on the head. To really secure those marks, you absolutely must use the deconstruct, solve, evaluate sequence. First, you identify the given information, like those specific beak sizes. Then, you break it into logical steps, solve systematically, maybe calculating the statistical difference if the question calls for it, check your biological reasoning for reasonableness, and finally, make a fully justified recommendation or conclusion based entirely on that data. This sequence is literally what saves your interpretation marks.
All right, moving on to Section 4, Top 3 Examiner Warnings.
Listen, knowing the framework is really only half the battle. What we have here is direct feedback straight from the Cambridge Principal Examiner reports outlining the top 3 massive traps. Examiners see these devastating mistakes year after year, and ignoring them will cause even a beautifully reasoned answer to completely fail. Trap number 1, using the wrong terminology for the wrong context. Calling an ecological barrier a geographical one, that's an instant fail for that question. Trap number 2, forgetting to check units and terminology when handling data from the stimulus. And trap number 3, providing generalized textbook answers that are not specific to the unique context given in the exam. If the question is about a specific species of cichlid fish, your answer must revolve entirely around those cichlid fish, not just generic populations.
So the crucial point here is this. Use this memory hack. Always, always define your terms before using them in extended responses. Seriously. If you're about to discuss sympatric speciation, just start your paragraph by briefly defining it. This instantly protects you against that most common terminology trap we just talked about. It proves to the examiner right out of the gate that you know exactly which context you're operating in before you even begin your data analysis. It's a massive quick win that takes just a few seconds.
And finally, we reach Section 5, the diagnostic cliffhanger. We've covered the foundation, the procedural steps, and those deadly examiner traps. You now have the exact architecture to build a perfect response. But remember that hidden clue I mentioned earlier? I want to leave you with this really provocative thought. Why will a perfect answer framework fail completely if you misread a single command word at the very start of the question? Think about it. If the examiner writes explain, but you simply describe, your entire top-band strategy collapses in an instant. Those command words dictate the exact mark band you're placed in.
You absolutely cannot afford to misinterpret these commands. To uncover exactly how to decode Cambridge command words and guarantee you're answering the right question every single time, you've got to take the next step. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Practice past paper questions using this speciation framework we just went over, and I will see you in our next explainer where we solve that exact command word mystery. See you then.